guys, it's 110 Octane, and today I'm going to be explaining to you a phenomenon that goes on with turbocharged engines known as turbo lag. So this turbo lag goes on with most turbocharged engines, and it's a problem that engineers are trying to combat, and today I'm going to explain to you how it works. So basically a turbocharged engine works as such as I've shown in this diagram. When you press the throttle, some air gets sucked into the cylinder. Second step, the cylinder combusts the air and the fuel together. After the fuel leaves the cylinder through the exhaust in step number 3 and enters the turbine. So in a turbocharger, the turbine is simply this wheel which the exhaust gases spin, kind of like in a hydroelectric dam, the flowing water spins a turbine. Except what happens here is that turbine is connected to another fan called a compressor. So it's connected by a direct shaft, and that compressor draws in fresh air and kind of like a fan sucks in that fresh air and blows it into this pipe. So at much higher pressure. It's kind of like how a vacuum cleaner sucks in air and blows it in at a much higher pressure. After that compressed air that comes from the turbocharger goes to the intercooler, which basically cools down the air to increase its density, and more air means more fuel combusted, which means more power. And finally, after the air leaves the intercooler, it goes back through the throttle and finally re-enters the cylinder. But now, since you have way more air, more fuel can be injected, therefore more fuel can be combusted, and therefore the engine will output more torque. Unfortunately, this entire process takes a lot of time. From when the throttle is initially pressed, what steps are there? So the throttle is initially pressed, some fuel, imagine a turbocharged sound, just some fuel enters the cylinder and some amount of air, because the turbo is not spooled up yet. So that amount of fuel combusts, some amount of exhaust comes out, and then all that exhaust has to spool up this turbine. So unfortunately, this turbine is pretty heavy, and it takes a bit of time for the exhaust gases to spool this turbine up to maximum velocity. So after the turbine is spooling up, some more fresh air is drawn into the compressor, which is driven by the turbine, goes in through the intercooler and back into the cylinder. So from step 1, when we initially press the throttle, to when the turbo fully spools up, takes a lot of time, and that time is known as turbo lag. A good way to visualize turbo lag is kind of if you actually turn on a fan yourself. So I'm going to turn on this fan to speed setting 1. So it took a bit of time from the fan to actually go from a standstill to spinning at its full velocity. So it's kind of like, imagine instead of here where the fan is being driven by an electric motor, it takes a bit of time for this rotating mass to accelerate. Similarly, when you're spinning this turbine over here, when the exhaust gases go through a turbine, it takes quite a bit of time for the turbine to go from spinning to a low velocity, for it to accelerate and spin up to high velocity, and that primarily causes a lot of turbo lag, as you see in vehicles. So when turbo lag happens, what are some problems about turbo lag? So as you can see in this graph, what happens is that let's just say I press the throttle. So over here, this is going to be my time over here. So this axis is going to be my time. There's going to be my full time on full throttle. So let's say at time 0, I jam on a throttle. That means I'm just coasting on at 60 miles per hour. I jam the throttle. Well, at this time, it's going to be taking the turbo some time to spool up. So what happens at the moment I press the throttle, as you can see, not much gases are flowing to a turbo, so it's not spinning so fast. And consequently, not many gases are coming out of the turbo, and not much is going back into the cylinder. So it takes a bit of time for the turbo to spool up and for more gases to get compressed and go into the engine. So as my torque output of the engine slowly increases, my turbo speed increases and more air gets sucked in, until eventually my turbos reach maximum speed and I'm pushing as much air into the engine as I can. So this period over here is called turbo lag, and as you can see, you do not actually have the full torque output until you've overcome this turbo lag. So although this turbo lag is not really long, may at most be a bit over a second or something on really bad scenarios, this does result in a few problems. One being delayed acceleration. So the moment you jam your throttle, you do not actually get full acceleration until you've overcome the turbo lag. This sudden surge in power may result in loss of control of your vehicle, because you may not be expecting the vehicle to surge forward because of turbo lag, and you may lose grip of your tires, resulting in wheel spin. So as you can see, turbo lag can actually be a pretty dangerous occurrence in some vehicles. On more high-performance turbocharged vehicles, turbo lag is not too big. It still is a problem because it cuts down sometimes on lap times, and it can become really annoying in day-to-day driving. One way to avoid turbo lag is really easy to use a smaller turbocharger. Because a smaller turbocharger has less mass that the gases have to overcome, so therefore it can spool up to its maximum speed quicker, and therefore you will get your maximum torque at a much less turbo lag. Thank you for watching this video. Please like and subscribe and feel free to comment down below. Peace out from 110 Octane.
Drift away.